Limits are an important topic in calculus, and in this video I'm going to be talking about the mechanics of them and just some notation. So to start off with, a basic definition here looks like this. You read this: the limit as x approaches a of f of x is L. So what does that mean? Basically, it means that as the x value gets closer and closer to some targeted value that I've called a, the f of x value, the y-coordinate, should be getting closer and closer to some other value that I've called L. How close? Well, as close as you want. This is kind of a tricky part for a lot of people, but really that's the definition. You get as close to L as you want. We have different kinds of limits. There are what is known as the one-sided limits, and there are two of them. There's the right-hand limit, which we indicate by putting a little plus on the a. It looks sort of like an exponent. Basically, this means that we're going to choose our x values to be numbers that are a little bit bigger than a. It's called the right-hand limit because if you think about a number line, these are all numbers that will be to the right of the special value. I usually think of the notation as helpful because it gives me the idea that it's a plus a little bit more. We also have the left-hand limit. For this, we use a little minus sign to indicate it. It means what you think it would. Our x values are numbers that are going to be a little bit smaller than a because those numbers would be located to the left of our special value on the number line. Once again, I think that the notation means that it's a minus a little bit. We also have the two-sided limit. We indicate that this is a two-sided limit without putting anything special on the number a. The two-sided limit means that x is approaching a from both sides, a little bit bigger and a little bit smaller. These three limits work together. Basically, you have two situations. If your right-hand limit and your left-hand limit equal each other, then all three limits, the two one-sided limits and the two-sided limit, are all the same value. On the other hand, if your one-sided limits do not equal each other, that means that the two-sided limit does not exist, or DNE for short. So here's some examples. If the limit as x approaches 2 from the right-hand side is 5, and the limit as x approaches 2 on the left-hand side is also 5, then those match. So if we want to figure out the two-sided limit, then it is just 5, because that is this, all three limits have to have the same value. For my next example here, I have x approaches 7 from the right-hand side and from the left-hand side. And as we can see, the limit from the right-hand side is 2, and the limit from the left-hand side is 9. So if I want to find the two-sided limit, I have to ask this question: are 2 and 9 the same number? Which they're obviously not. So that means that the two-sided limit does not exist, because 2 and 9 are not the same number. For my next example here, this is a little different. I have the limit from the right-hand side and from the left-hand side are both infinity. When it comes to limits, nobody ever said that the limit had to be a number. Infinity is not a number, but it is a perfectly good answer. So the left-hand limit and the right-hand limit have the same answer. Therefore, the two-sided limit is the same answer as well, which is infinity. All that matters is if the left-hand limit and the right-hand limit match. Here's another example. I have the limit as x approaches 4 from the right is infinity. The limit as x approaches 4 from the left is minus infinity. These are not the same thing. That means that the two-sided limit does not exist, because a very large positive number and a very large negative number are not the same thing. I want to end this on a slightly pedantic note. Please never say that the limit equals does not exist. People do it all the time. It's not wrong, but if you say that, that means the limit as x approaches a of f of x does not exist. Does is not a thing that people say. It's not wrong, but it always makes me cringe.